Hi guys, this is section 1.1 in Algebra 3, and this will be an introduction to graphing, and a lot of this stuff you will be familiar with already. A lot of it is a review from Algebra 1. We're going to be plotting points. We're going to figure out if points are solutions to equations. We'll be doing some graphing of equations using the x and y intercepts, and then some things that might be new today or a bit from long ago will be distance between 2 points, equations of circles, and midpoints as well. Okay, first thing we're going to talk about the coordinate grid or the Cartesian coordinate system plane. We plot points here to keep track of ordered pairs. And this is quadrant 1. We do use Roman numerals. We do counterclockwise. 2 would be to the left, 3 would be here, and then this is quadrant 4 or IV. Okay, both of these points are positive. This one you would go to the left, so it'd be negative and then positive. Both coordinates here are negative, and this would be positive and then negative for the x and then the y value. So a little refresher, how do we plot these points? First we go left or right, and then we will go up or down. So when you plot negative 3, 5, they showed you go negative 3 in the x direction because this is the x-axis. So you go 3 to the left, and then you go 5 up in the y direction, and it's positive. So negative 3, 5 would be this point right here on our coordinate grid. Okay, that was me trying a new slide. All right, so let's talk about solutions. One thing when you guys are taught Algebra 1, what a lot of kids don't understand really is what's happening with a line. Okay, so this is an equation, 2x plus 3y equals 18. And there are lots of things that make this true. 2 times the number plus 3 times the number is 18. Okay, so we could say, well, if x is the number, let's say x is the number, so x equals 1. So 2 times 1 plus 3 times something equals 18. So 2 plus 3 times something is 18. So minus 2, and this was kind of a bad example for me to pick. 3y equals 16. So if x is 1, y has to be 16 thirds, which is about 5 1/3, right? So that's one point that can make this equation true. There are other points that could make it true as well. X could be 2, and something could make that true. X could be 1.5. So there are infinitely many points that make this equation true, which is why we end up graphing the line. And if we were to graph this line, and we're going to talk about graphing it in a minute, let's pretend the line looked like this. And I don't know what the line looked like because I haven't graphed it yet. Every single point that's on the line would be a combination of numbers that would make this equation true. So there are infinitely many solutions that you could pick. Now we like to pick these nice lattice points like 1 and 2 and 3, but there's all those in-betweener points. Like if x is 1.2, I can do the same math I just did to figure out what y would need to be, and it would also be on that line. So when we have solutions to these equations and there's 2 variables, there are infinitely many solutions that we are going to try to dig through. So what they're going to ask us is to figure out if an ordered pair is a solution. So they're asking if an ordered pair is a solution. What we're going to do is we will just plug it in to see if true. So we're going to see if this is true by plugging in the point negative 5, 7 into x and into y for the equation. So the work you would show me would be 2 times negative 5 plus 3 times 7. And we need to see, does that even equal 18? Well, I have negative 10 plus 21. Does that equal 18? No, that equals 11. So what that tells me is this is not a solution. It would not be on the line. If I was going to graph this line and pretend it looks like this, like I said, Negative 5, 7 might be up here or down here. It's definitely not on the line though, because the line is the picture of all of the solutions. Now let's see if 3, 4 would be on that line. Is it a solution? So x would be 3 and y would be 4, and we're going to see if we plug it in if it will be true. So 2 times 3 plus 3 times 4, does that equal 18? Because if it does, it would be on the line. 6 plus 12 does equal 18, so that means that point 3, 4 would be on that line. So how can we graph it to see the picture of all the lines? Well, there's lots of ways you can do it. You can make an XYT table. That's the first way we taught you way back when. Then we probably taught you to graph by the intercepts. A lot of kids do not remember how to graph by the intercepts, and that's okay. We'll go over it. And then a lot of you like to get y by itself, because if y is by itself, it's in ready to graph form or slope intercept form. And there's some shortcuts because there's some tricks we know about this. M would be the rate of change or how steep the graph is, and B is the y-intercept. So we are going to find the solution set or the picture of the solutions of these lines through graphing. Okay, so x-intercept. Don't get them confused. X-intercept means y equals 0. You always flip them. X-intercept means y equals 0. It is on the x-axis. So this is the x-axis and this is the y-axis. So an x-intercept could be 2, 0 because it's sitting on the x-axis. So y is 0. They called it A0 because it could be any point. All you have to do is let y equal 0 to figure out where it is. Y-intercept then means x equals 0 because it will be sitting on the y-axis. And if it's sitting on the y-axis, you would not go left or right at all. You would just go up or down in the y direction. So a y-intercept means x equals 0. And their example is 0b because you could go up or down depending if b is negative or positive. Okay, so we're going to find the y-intercept. It's asking for the y-intercept, so you can plug in x equals 0. This is the fastest, most direct approach, and that would be 2 times 0 plus 3y equals 18. The nice thing about plugging in zeros is a lot of times a big piece of the equation will drop out because 2 times 0 is 0. So 3y is 18, leaves us with y equals 6 after you divide both sides by 3, and I didn't show that step. The y-intercept is not just y equals 6, though. It's a point. It's the point 0, 6. It's an ordered pair. Now, some of you might have remembered, wait, y-intercept means b, and y equals mx plus b. You are not wrong. If you wanted to do that, you could get y by itself by subtracting 2x, and you would get 3y equals negative 2x plus 18. You would divide all the friends by 3. And you would get y equals negative 2/3 x plus 6. You would have to know this is the b or the y-intercept, and you would write it as an ordered pair 0, 6. It was a little quicker by plugging in 0, but this gets the job done as well. So it's not wrong if you would have thought to go that way. Okay, they want us to graph it. Now, they want us to graph it using intercepts. This is called standard form when you're adding the x's and y's. Intercepts are an easy, good way to graph. If you have it in standard form, because again, it's easy to plug in x equals 0, which would tell me the y-intercept, and you can plug in y equals 0 for the x-intercept. And the reason you're allowed to do that is because it only takes 2 points to make a line, and x and y intercepts would be the 2 points. So if I plug in x equals 0 here, eventually you wouldn't even have to write it. You would just see that it would drop out. This piece is going to drop out. Plus 3y equals 18. We already did this. So y is 6. So one of the points would be over 0, up 6. If y equals 0, this piece will drop out because it would be 3 times 0 equals 18. So this would be just 0. 2x equals 18. Divide both sides by 2. And our x-intercept is going to be x equals 9. And then you can connect the 2 points. Now, ooh, that's not too bad. It's hard. Again, it's not wrong if you would have got y by itself like we just did on the last page, and then you could have done the slope. Even though it's going to tell you to graph by the intercepts, I'm never going to police the way you choose to graph lines. I think it's faster to do this by intercepts, and if you get in the habit of starting to look at equations instead of just autopilot, get y by itself, you'll be a little bit more successful. But if you would have got y by itself and divided all the friends by 3 like we talked about, that's a negative. You have y equals negative 2/3 x plus 6. We did that on the last side, and look, up 6, down 2 over 3, down 2 over 3, and eventually you would get right back down to that point because there's other steps along the way that are also solutions, because this is a picture of all the solutions of that equation. You could have, they made a table here. You could have plotted the points making a table. Okay, next one. Let's try this one. It's a little different. Again, you could do the x or y intercepts if you want, but they're not going to be quite as easy here. For the x-intercept, that means y equals 0. If y equals 0, I get negative 2x equals 3. So one of the points is going to be x equals negative 3/2, which is the same thing as negative 1.5. So 1 point is going to be negative 1.50. Okay, then to find the y-intercept means x equals 0. If x equals 0, I will get 3y minus 0 equals 3, or just 3y equals 3. I'm getting a little shaky. I think it's the battery maybe, so I'm sorry if that freaks you out a little bit. Look at that. Oh my gosh. That's y equals 1. So x equals 0, y equals 1 is another point. So we get negative 1.50 and over 0 up 1 for another point, and you can graph it like that. 2 points is all it takes. Again, you could get y by itself, and you would get 3y equals, we would add 2x here, 2x plus 3, divide all the friends by 3. We get y equals 2/3 x plus 1. And you're up 1 here for your first point, and then you would go up 2 over 3. And there's another point, down 2 over 3. And that would be right here. This one just happens to be in between those points. Okay, how about if you're not graphing lines? How about if you're graphing something like this? Well, they're wanting you just to do an XYT table. You are happy and allowed to use your graphing calculator on some of these if you like, because we're going to talk about quadratics more in the future. And if you remembered things about completing the square, you also could have completed the square. Those of you who do remember things about completing the square should see this -9 though, and realize the vertex is going to be in between values, and it's going to be kind of hard to find. So your graphing calculator would probably be a good route here. If you don't have a graphing calculator, you can use Desmos, and there's also a nice app I found on my phone that's called Calculate 84. You are welcome to use that as well. This lesson is not about graphing quadratics, so I am just going to show you the table of values they picked, because it's just showing you how to plug values in. If you plug -3 in, you get -3 squared minus 9 times -3 minus 12. You plug that all in, and you will get the answer is 24. So when you plugged -3 in, you got 24, and that would be a point on your graph. You can hop around a little bit, but if you plug in 0, 0 is always easy to plug in. especially into quadratics and standard form. Minus 9 times 0 minus 12, you'll get negative 12. So that is a y-intercept. They keep plugging points in until they find what I call is the bounce. The bounce is where the rebound will happen so that you know it is going to be the parabola you're looking for, because you should know it's a parabola because you see the x squared. They keep plugging the points in until they get the graph they're looking for. Again, we'll talk more about quadratics in the next chapter. Okay, distance formula. This is a big thing. Kids do a bad job of memorizing the distance formula, and I'm going to tell you, you need to stop memorizing the distance formula. You need to know the distance formula. If I want to know how far apart those 2 points are, the distance formula, it's actually called the Pythagorean theorem distance formula. I'm like stuttering. Pythagorean theorem, because it's just the Pythagorean theorem. You're like, I don't see a triangle. Well, make one. You have nice little grid paper. If you know how tall this is, and you know how wide this is, then you can do the Pythagorean theorem, which is a squared plus b squared equals c squared. So let's call this question mark delta y. Delta means change in. This is a y value because it's a height. Okay, so if I have delta y squared, and this would be the change in x squared, it's delta x squared plus delta y squared. That will be what the distance squared would be here. But if you square root both sides, then this is where the formula comes from. The square root, the distance is going to be the square root of how far apart the x's are squared plus how far apart the y's are squared. And if you can see it like the Pythagorean theorem, this is going to make distance problems so much easier for you. Now, you're not always going to want to graph them, but we're going to on this first one so you can see what's happening. -1, -5 is right here. -1, 2 is here. Well, this is not a triangle problem at all. -1, -5, and -1, 2. How far apart are those? Well, just count. Just count how far apart they are. They're 7 apart. The distance is 7 between those. You can just count. So that's what you would do. On the next example, why didn't they do another one? I'm just curious. Well, they need to do another one, so we'll do another one. Oh, here's one. I must have skipped right over it. Okay, they want the distance between -2, 2 and 3, -6. Now here, you can't count them because it's not straight. So we will just draw in our little right triangle, and you'll ask yourself, how far apart are my two x values? How far is it from -2 to 3? And that's 5 apart. That's 5. How far apart is it from -6 to 2? Well, that is going to be 8 apart. That will be the distance squared. 25 plus 64 is the distance squared. That gives you 89 is the distance squared. And they want an exact answer, so you'll just square root, and you'll tell me the answer is the square root of 89. Is it wrong if you want to use the formula? No, it's never wrong to want to use the formula. It's wrong if you don't know the formula. And my problem is a lot of kids cannot remember the formula. You are welcome to memorize it and use it. But if you know that it's Pythagorean theorem, it's going to be much easier for you. Because if you do the formula, you will plug in what the x2 is. So that's what? This is x1, y1, x2, y2. -6 minus -2 squared plus -6. Did I do that wrong? X2 is first. Yeah, I did. x2, sorry, x2 is 3 minus 3 minus -2 squared plus -6 minus 2 squared. 3 minus -2 becomes 5 squared plus -8 squared, which becomes the square root of 25 plus 64, which is exactly what we did using Pythagorean theorem, because it's the same thing. So if you want to try to do those points without using the formula, that might be good practice for you. Okay, next they're talking to us about circles, and they want us to figure out what they're asking. If the point -2, 5 is on a circle, and 3, -1 is a center, that's the center, find the radius. So that means if that's the center, then your circle is going to go kind of like this. That's kind of actually really good, what I just did there. Oh my gosh. Like if you're impressed right now, that's probably really, you should be, because that was freaking awesome. Okay. So they want to know what the radius is. So they're asking just what is the distance from the center to that point. So again, you can use Pythagorean theorem. You could draw in the right triangle, or you could just ask yourself, how far apart are these x values? How far apart is it from -2 to 3? And they are 5 apart. How far is it from 5 to -1? Well, that will be 6 apart, because 5 to -1 is 6. That's going to be the distance squared. 25 plus 36 is the distance squared. 61 is the distance squared. So this radius is going to be the square root of 61. The midpoint formula. Midpoint formula is the middle point. It is the average. So you just need to know what is the average of the x's and what is the average of the y's, and that will be your middle point. That is your formula. Add the x's, divide by 2. Add the y's, divide by 2. So in this example, where will the midpoint be? It's always nice to kind of eyeball it before you go, just to see if you can guess where it would be. But if I had the average of the x's and I take -4 plus 2 divide by 2, that'll be -2 over 2, which is -1. If I take the y's and divide by 2, -2 plus 5 divided by 2 is 3 over 2, which is 1.5. I get -1, 3 halves, or 1.5, and that is what looks to be the midpoint, and it is. Okay, this time they're talking about a diameter of a circle. So you have a diameter of a circle, which goes all the way across. And you have one point at 2, -3, and one point at 6, 4. And I put my points in really weird spots, so that's not quite right. But they want to know what the center is. So what are they asking for? They're asking me for a midpoint. And again, my picture was bad. You can make a nicer picture. That might have made more sense to you if you draw it out. But they're just asking you for the midpoint. 2 plus 6 divided by 2 will be the middle point of the x's. 8 divided by 2 is 4. -3 plus 4 divided by 2 is the middle point of the y's, and that would be 1 over 2, or 1/2, or 0.5. Next, we're going to look at circles. Here is the formula for circles. Circles is a set of all points that are the same distance away from the center. And it comes from the distance formula. Because they're going to try to get rid of the gigantic square root. So what the formula is, and how kids remember it, is they say you find your center and you find your radius. You're going to change the sign of the x, and you're going to change the sign of the y. So if the center was 2, 4, and the radius was 5, I'm going to change the sign of the 2, so it'll be x minus 2 squared, plus change the sign of the y minus 4 squared, and it always equals the radius squared. It does come from the Pythagorean theorem, so it has that look of the Pythagorean theorem there. We would go ahead and finish that out and say 25, but these guys, they're going to let you just leave in parentheses, I think. Later, we'll talk about conics, I think, second semester, where we'll do some more expanding with that. They just want you to change the sign, equal the radius square. Okay, so on this one, we will change the sign of the x, so it'll be an x minus 3 squared. You always have to have those squares, plus a y minus a negative 7 becomes a plus 7 squared equals the radius squared, which is 25. Okay, we can go ahead and graph that as well. When you graph it, you'll go to 3, negative 7. You'll put your dot, and you'll just count 5 up, down, left, and right, and then draw your circle. 1, 2, 3, 4, 5, and 5 down. 1, 2, 3, 4, 5. This is gonna, mine's so crooked. This is so bad. Okay, you might be crying and weeping. Okay, that was not good. That is sad. That's a sad circle. Okay, so I'm sorry that happened, but you'll survive. Okay, we're almost done. One more of these to graph. I'm not going to graph it because I just showed you. This would be negative 5, 2, but the radius squared is 16. Be careful there. The radius squared is 16. If the radius squared is 16, when you square root it, it's going to be 4. Now, where did I get the negative 5, 2? Change the sign, and then you would count out your radius and you would graph it. Okay, your calculator can graph circles, but it is kind of a waste of time. I'm not even going to spend time with it because I never do it, and it doesn't help you. Graphing circles is better by hand, but if you'd like some to play with your graphing calculator, feel free to do that. Okay, that's it for the first notes.